हेलो फ्रेंड्स, तो आज हम करने वाले हैं कंप्लीट फॉर्मूला रिवीजन ऑफ चैप्टर सॉल्यूशन ऑफ केमिस्ट्री फॉर क्लास 12th plus MHT-CET. So let's begin. In this first one is solute plus solvent. If it is dissociated, then it will become the solution, and if the solution is crystallized, then it will become the solute plus solvent. Okay. Next one is a type of solution. If the state of solute is solid and state of solvent is liquid, then example is seawater and sugar in water. Okay. And if the solute is solid and solvent is also solid, then example is alloy such as brass, bronze. Okay. And if the solute is solid and solvent is gas, then example is iodine in air. Okay. And if the solute is liquid and solvent is liquid, if both are liquid, then example is gasoline and ethanol in water. Okay. And if the solute is liquid and solvent is solid, then example is amalgam of mercury with the metal as mercury in silver. Okay. And if solute is liquid and solvent is gas, then example is chloroform in nitrogen. Okay. And if solute is gas and solvent is liquid, then example is CO2 in water and O2 in water. Okay, these are the examples. And next one is if the solute is gas and solvent is solid, then example is H2 in palladium. Okay. And if solute is gas and solvent is also gas, then example is air, in which O2, N2, argon and other gases are involved. Okay. Next one is factor affecting solubility. First one is nature of solute and solvent. That means substance with similar polarity. That means like dissolve like tend to dissolve more readily. Okay. Next one is temperature of effect of temperature on solubility, in which solubility of solid generally increases with temperature, while the solubility of gas decreases with temperature rise. Okay. Next one is effect of pressure on solubility. Okay. Solubility of gas increases with pressure. Okay, as described by Henry law, while pressure has a little effect on the solid and liquid. Okay. Next we see the Henry's law, in which solubility is equals to Henry law constant into pressure of gas. Okay. Unit of Henry constant is mole, liter inverse, bar inverse. Okay. Next one is Raoult's law. It stated that the P1 is equals to chi1 P1 naught and P2 is equals to chi2 P2 naught, where P1 and P2 are partial vapor pressure and X1 and X2 are mole fractions, and P1 naught and P2 naught are vapor pressure of pure liquids. Okay. Next one is the Dalton's law. Dalton's law is stated that the total pressure is equals to sum of all pressure. That means P1 plus P2, and here P1 is chi1 P1 naught and P2 is equals to chi2 P2 naught. Okay, and we can solve this by using the chi1 plus chi2 is equals to 1. Okay. Next one is a composition of vapor phase. Okay. Vapor phase Y1 and Y2. Y1 is equals to P1 upon P and Y2 is equals to P2 upon P, where Y1 and Y2 are the mole fraction in vapor phase. Okay. Next one is ideal solution. Ideal solution means that solution which obeys the Raoult's law and have the change in enthalpy is equals to 0, and change in volume is also equals to 0. And next one is solvent, solute, solute and solvent molecular interaction are comparable. Okay. And example of ideal solution are benzene plus toluene, N-hexane plus N-heptane, and ethanol plus methanol, etc. Okay. Next one is non-ideal solution. Non-ideal solution are those solution which do not obey the Raoult's law. Okay. In this only there is two deviations, positive deviation and negative deviation. In the positive deviation, solute solvent intermolecular attraction are weaker than the solute and solvent solvent molecules. Example of positive deviation are ethanol and acetone, And next one is CH2, that means carbon disulfide and acetone are the example of positive deviation. Next one is negative deviation. Negative deviation means interaction between solvent and solute molecular stronger than solute or solvent interaction. Okay, the example of a negative deviation are phenol and aniline, and also chloroform and acetone. Okay. Next one is a colligative property of non-electrolyte solution, in which first one is vapor pressure lowering. In this, delta P is equals to P1 naught into X2, where X2 is mole fraction of solute. Okay. Next one is a relative lowering of vapor pressure. That says delta P upon P1 naught is equals to X2, which is a mole fraction of solute, that is equals to P1 naught minus P1 upon P1 naught, where P1 naught minus P1 is delta P. Okay. We can also write X2 as a W2 into M1 upon M2 into W1, where P1 naught is equals to vapor pressure of pure solvent, P1 is vapor pressure of solvent, and W2 is weight of solute in gram, and W1 is weight of solvent in gram, and M1 and M2 are molar masses of the solvent and solute respectively. Next one is second one is boiling point of elevation. That says delta TB is equals to KB into M, where M is molality. Okay, and also delta TB is equals to TB minus TB naught, that is equals to KB into M. And we can also write as delta TB is equals to KB into 1000 into W2 upon M2 into W2. Okay, where TB is boiling point of solution and TB naught is boiling point of pure solvent, and KB is equals to boiling point elevation constant or molar elevation constant or ebullioscopic constant. Okay, and M is molality of solution. Okay, and from there we can write M2 is equals to 1000 into KB into W2 upon delta TB into W1. Okay, and unit of KB is K, which is Kelvin into kg into mole inverse. Okay, and here is a diagram of boiling point elevation. Okay, next one is third one is depression and freezing point. That's delta TF is equals to KF into M, where M is molality. Okay, delta TF is equals to TF naught minus TF, that is equals to KF into M, and we can also write as a delta TF is equals to KF into 1000 into W2 upon M2 into W1. Okay, and where TB is freezing point of solution and TB naught is freezing point of pure solvent, and KB is equals to freezing point depression constant or cryoscopic constant, and M is molality of solution. Okay, and next one is M2. M2 is equals to 1000 into KF into W2 upon delta TF into W1. Okay, unit of KF is Kelvin into kg into mole inverse or degree Celsius kg mole inverse, and here is the diagram of the depression in freezing point. Next one is osmotic pressure. Osmotic pressure is denoted by pi, that is equals to MRT, that is equals to W2 into RT upon M2 into V, and we can also write as M2 is equals to W2 into R into T upon pi into V. Okay, where pi is equals to osmotic pressure, M is equals to molarity, and R is equals to gas constant. Okay, the value of R is 0.0826, that is approximately equals to 1 upon 12. Okay, we can write as 1 upon 12 decimeter cube into atm per Kelvin per mole. Okay, next one is isotonic solution. In the isotonic solution, if two or more solution having same osmotic pressure, that is pi 1 is equals to pi 2, and hypertonic solution says that if two solution have unequal osmotic pressure, the more concentrated solution with higher osmotic pressure, okay, that is pi 1 is greater than pi 2, okay. And next one is hypotonic solution, more diluted solution exhibiting lower osmotic pressure, that is pi 1 is less than pi 2, okay. Next one is Ventop factor, which is denoted by small I, and I is equals to colligative properties of electrolyte solution upon colligative property of non-electrolyte solution of the same concentration, okay. And it is also equals to actual moles of particle in solution after dissociation upon moles of formula unit dissolved in solution, and also equals to formula mass of substance upon absorbed molar mass of substance, and also theoretical molar mass upon observed molar mass, okay. Next one is the colligative property of electrolyte solution, okay, in which we multiply with the Ventop factor and we get the colligative properties of electrolyte solution. For example, first one is delta P is equals to I, which is Ventop factor, into P1 naught into X2, and second one is delta TB is equals to I into KB into M, and third one is delta TF is equals to I into KF into M, and fourth one is pi is equals to I into M into R into T, okay. Next one is a relation between Ventop factor and degree of dissociation. This is I is equals to 1 plus alpha n minus 1, or we can also write as alpha is equals to I minus 1 upon n minus 1, where alpha is the degree of dissociation and n is equals to x plus y, that is equals to moles of ion obtained from dissociation of 1 mole of electrolyte, okay. Thank you for watching the video till the end. You can download the PDF from our Telegram group. I will give the link in the description. You can go and check out from there, okay.